Okay, Assalamualaikum and good morning, everyone. So, this is actually preparation for your lab 2, right? So, in this lab, what you will do is actually you will use another software, okay, still under Synopsis, okay, we call it as IC compiler, okay. To start the lab, you go to the working directory of your folder. Okay, remember that we have successfully finished lab 1 and lab 0. Okay, so you have all the source file, okay, including the multiplier underscore syn.ddc. So this is actually the file that is required for your lab 2. Okay, for your lab 1, you have already created multiplier.v, okay, and multiplier underscore test bench, okay. So that file has been used for VCS in your lab number 1. Okay, Verilog compiler simulator. You have performed the uh, functional or behavioral verification of the code. Then you have used design vision. Sorry, design vision, synopsis design vision. That one second software under the package of Synopsis. We use that software for synthesizing our Verilog HTML code to equivalent logic gates. Okay, all right. And then for the IC compiler software, which is a third software package under the Synopsis, we will be using the what we call that software for creating the layout of our design. Okay, so in my case, I already copied my source file folder, the source under the lab2. Okay, you those who don't have we did not we those who did not yet okay copied it, please do so. Okay, so these are the file. Okay, the most important one, which is this one, .ddc file. Okay, once everything is okay, then you can right click and open in terminal. So then from there you can check whether you are currently having that file or not. So we can see it clearly, multiplier syn.ddc. And then we can also check our current working directory by typing pwd. So this is actually our current location, lab2 under folder src. Okay, all right. So what's to do next? So we need to source the Synopsis because we want to use the Synopsis software. We need to do this first. Then once everything okay, and then you type IC compiler so that it will. Sorry, not IC compiler. IC compiler is the name of the software. To launch the IC compiler, you need to type this ICC underscore okay, shell, then white space dash GUI. Okay. Remember, don't forget the white space. So this is actually the white space. And then after the white space, you have dash and then GUI. GUI stands for graphical user interface. Means that we want to run the ICC shell using graphical user interface, not the command prompt. Okay, not the command prompt way. Okay, then you enter. Okay, it's loading. Okay, and then we see the GUI, graphical user interface for the IC compiler. All right. So to do the lab, okay, we need to have a few steps. Okay. So as I mentioned in the early or in the beginning, our step is actually for performing layout synthesis. Okay, layout synthesis. So previously under lab 1, we have performed logic synthesis and optimization. And before that, we have done RTL coding and simulation using Verilog HTML. And then we have finished compiling the design using design vision, okay, logic synthesis and optimization. And now we are actually perform a layout synthesis, or sometimes we call it automatic place and route. Okay. Okay, so in this exercise or in this recorded video, we will be working actually in the outline this portion of the basic design flow. Okay, and we will use the Synopsis product family for synthesis. So in particular, we focus on the IC compiler lah, basically. All right. So to do it, okay, we have open the IC compiler GUI. Okay, and we also have the log file here and also the history file. Okay, this is very important uh, tab lah. Okay, and for you to trace the action taken during the lab session. Okay, so what you need to do first, you need to set up the work environment. Okay, actually work environment referring to the actually to the library lah. So I maximize this one. Okay, the GUI, and then open the file, sorry, and then we create library. Okay, file, create library. So we have all this. I think you're familiar with the this one in lab number one. Okay, design vision. So same as design vision, we still need to set the library. Okay, so to set that library, first we need to name our design. Okay, our new library name, for example, multiplier.mw. Okay, and then we need to refer it to a technology file. Okay, so normally the technology file is under the EDA folder. Okay, and then ref, and then tag, and then this is actually the library, the technology file. Okay, we are using this file. Okay, then we set it. Okay, and then input reference libraries we need to uh, add. Okay, still under EDA. You browse for EDA, and then ref, and then MW library and SC. So under SC we have cell. Okay, we have FRAM, and then we have LM. So we just select the SC folder. Okay, and then you choose it. You should be able to see it appear here. Okay, and don't forget to put dot here. Okay, dot. Okay, and then what to do next? We click on Open Library. Okay, and then I think we have finished setting up the library. Okay, creating the library, and then once you finish, and then we can click OK. Okay, so keep looking into the log file and see what's happened. So if the warning appears, don't worry. Okay, it's just information for you. Okay, and then we can see under the history tab we have already created the library. Okay, here is a detail and the library name is multiplier.mw. Okay, we can also perform task number 2 using the command line, which is under the ICC underscore shell. You can use the shell here to create the same way as this one. Okay, this is actually the command. Okay. All right. So next, we need to set up what we call as our application. We do application setup. So to do it, you go to File, okay, File Setup, and then Application Setup. Okay, so I think all of you familiar with this application setup window or dialog box. We have done this in our lab number 1 under design vision. Okay, synopsis design vision. So what you need to do in this one, the search path. The search path you need to set it to a different location. Okay, so you remove all the other path lah, delete. Okay, and then you add a new one. So the path is under EDA, okay, ref and DB. So this is actually the path. And then choose it, delete the other path lah. Okay, and then you click OK until you see the blue color, means that it's okay, the path is searchable. And then for the link library, we go find for sc underscore max db. Okay, we delete this, delete, and then we go find sc underscore max db. So this is the file. Then you open it, and then you OK. So clearly we can see the blue line is here, and that means it's okay. And for target library, you delete it first and then add a new one. So always delete lah, the previous location, so that your lab will run smoothly. And then for the target library, we also choose the same sc underscore maxdb, max.db, and then we open it, and then we OK, and then you see everything is okay. Okay, for this case, the symbol library, we didn't assign any symbol lah. Okay, we can delete this. Okay, or you can go click here and then you can delete manually. In this case, it's already deleted. All right, so and then if everything is okay, and then you click apply, and then it will apply for you lah. Okay, all right. So to double check, you can go to log history, and then you see it is already set lah. Okay, that file. Okay, you can even go back and check lah to make sure that it's okay, because we see in this history only 2 lines, but we did the third step. So to double check, you go to the same setup lah. Okay, so it's already here, means that that is set up for you lah. No need to change the variable. Okay, so it's okay. All right, so what to do next? We set up the TLU. Okay, so what is TLU? Okay, TLU, I just give you idea lah. TLU is related to the timing, if I'm not mistaken. So you can go check it and then report in your report lah. Okay, you can get this information from the Synopsis manual lah. Detail of the manual is available under their website. Okay, Synopsis website. All right. So what's to do next? Set the TLU. Okay, how to set it? So file, set TLU plus. Okay, and then we have max TLU and min TLU. Okay, and then we have a layer name mapping file between technology library and IDF file. So first, max TLU. What is it? Max TLU? So we need to go find that library as well under reference. So go to same folder, EDA, I think ref, yeah, and then TLUP library. And then we go for maximum, and then we open it. And for minimum, we go for minimum. Okay, again, we go to the EDA folder. Okay, and then ref library, TLUP, and then we go for minimum. Okay, and then for the layer name mapping, we go choose the other file. Okay, same, go to the EDA ref, and then I think TLUP, and then CB13, okay, underscore 6, this one, and you open it. Okay, please make sure that you have selected the correct file so that you will not miss the step or your lab getting problem. Okay, and then you OK it, and then the third step is actually we have already set the TLU, right? Okay, what's next? We can also use the command similarly to create the same TLU file setting using the IC shell. And then we will import our design, our multiplier.ddc file that we have done in our previous lab. Okay, to import it, we go to file, okay, import, and then you go to read DDC. Actually, we have two options here, read very long and read DDC. So in this case, we want to read the DDC file generated from the lab. If let's say the DDC file not okay, you may try to use read very long, whereby you read the original Verilog file multiplier.v. So in this case, we read the generated DDC file in our lab number 1. Alright, so this what we call read DDC dialog box will appear, and then it will ask you, okay, to add that file. So you go and then browse for that file. Remember the location that you have saved your file, okay, which is this one. Okay, this is actually the DDC file. Okay, you have it already, and the name of the file. Wait, I'm not sure whether we have, just to make sure that we have import the correct is correct step. I think file import design import. Under import we have only, oh, here, sorry, I make a mistake, so please ignore that step, okay. So import design, not import, okay, import design. All right, here the correct one, we have DDC and Verilog. So now we choose again the DDC. I'm sorry about it. So the DDC, okay, we have it already, and then the design name must have the same design name lah. So multiplier, and then the cell name also multiplier, and then once everything is okay, and then you click OK. Wait for a while for your design to be imported. Okay, so we have 34 errors and one warning message were generated. Here are the first 5. Okay, if you get that error, don't worry, you just click OK. Okay, as long as your step here we have step number 4, and then log file have all the information lah, including the error. So normally this error is related to the design rule error lah, unable to resolve the reference and so on. Okay, don't worry about this. We go to the next step and see what happened. So, and then we open our design in the column. Okay, to do it, we go to File, Open Design. Okay, then select multiplier, already selected. Okay, and then you click OK. Okay, now we can see our multiplier. Okay, you can make it bigger. All right, so what's to do next? We will define the power rail. Okay, so when we perform that, that task will eliminate the actually the errors lah. Okay, we will do the power rail, we create a floor plan. Remember the lecture on floor plan we have discussed in class, and then we add power rings. Okay, and then next I think we do a place and route and optimization, and finally we will get the layout lah. Okay, we will do it step by step as we go along to this lab demonstration, recorded video demonstration. So we have already opened our design, and what's to do next? So this time we try to use what we call the shell. Okay, we will try to use the shell. Okay, we minimize this. Okay, we have the shell, ICC shell. All right, we try to use this. Okay, first we add the power rail. Remember our design. Okay, we have power rail at the outermost. So what to do? We set the VDD first. Okay, we type here set the VDD. Okay, okay, we set the VDD. Then you enter. Okay, wait for a while. It will take some time. It depends on computer lah. Maybe my computer is not fast enough lah. Okay, let me check again. Always use the window button to make sure everything is active. set the VDD and still not working. I don't know why. So it's okay. Try again. Maybe we can delete. We minimize this and delete this. Okay. Delete the VDD and do it again. And then enter. Okay. Now it's set. Okay. Now, how do you know it's set or not? It replies to you the VDD. Then you can check the layout as well. You use the window button and then click on the layout. Okay, and then type the new command lah. If it's we try make it side by side lah, so that everyone can see it clearly. See the changes lah, what I mean here. Okay. Make it side by side. Okay. Alright, so what's next? Okay, now it's active. And then we set the ground. Set the ground. So ground. Set ground. Go to VSS. Okay. We set ground VSS and then see it respond to you. And that is recorded lah, VSS. And then we set power port. Okay. VDD. Okay, and then we set the ground port. Okay, and then what we need to do is we set the detail of the VDD port. Okay, I think this one. Okay. So now top power port VDD created, total one port created. So we can maybe here we still cannot see it clearly. Okay, so total one port created, connected 34 power port and 0 ground port. Not yet lah for the ground port, and then we do it for the ground port. Remember to remove this lah. Okay. Make it like this one. Then enter. Okay. VDD, VSS, okay, we have done it, and then we derive. Okay, don't worry about the warning. Okay, so now we linking the multiplier, and then now we have successfully performed that task. Okay, what to do next? Okay, we will use the IC shell command input to communicate with the software actually. So this is one way. Another way you can use the pull down menu here lah. So we just demonstrate the two ways lah. Okay, we will do the next, which is the floor planning. Okay, so to do floor plan, you can also use the what we call the GUI. Okay, go to floor plan. Okay, and create floor plan. Okay. You need to find here lah, floor plan. I think it's in here. Good. Yeah, here you need to activate. Okay, okay, floor plan and create floor plan. Right. Okay, we want to create floor plan. So this one. This is actually the GUI way lah. Okay, you enter it. Okay, what is actually the core utilization? Okay, you can set it here. Okay, and then we set the aspect ratio here. Okay, I just inform you the important parameters that we need to set. So left IO cost. Okay, this one. Okay, bottom, this one, right, and also top. So we set the dimension. Okay, okay, we can perform this way, okay, or we can also type using a ICC shell, okay. All right. So let's say we set it using ICC shell, okay. Cancel it. Okay, we go back to our ICC. So again, use the window button, okay, and then use the ICC shell. So we can set what we call comment lah for our code, okay, for us to easily trace it in our log file. Okay, so we're performing a floor plan. Okay, and then we create the floor plan using the ICC command. Okay. So the dash, the slash here is actually to create a new line of the command lah. Actually, if you want to make it as one line, you just remove it and then bring the below line to the top. Okay, until we have a straight one line. Okay, but we have a problem on the readability of the line. So the best way we do this. Then you enter. You can see the ring is here, and then we have see all the location lah. See the effect. Maybe I move my face down here, then everyone can see it clearly. All right. So what to do next? We add the power ring. So how to add the power ring? As I mentioned, we can also use the GUI. Okay, and the use the always use the window button lah if you want to, okay, access to it. Okay, so and then pre-route. So pre-route is, I think, somewhere we need to maximize this. I think pre-route. Okay, oh yeah, this one, and then create ring. Okay, create ring. So this is one way. Okay, what we do is actually we set the net first. Okay, create rectangular ring for the net. So we have VDD and VSS. Okay, net. So we need to set it. Okay, we go to, I think, rectangular. Okay, and we have also rectilinear. This. Okay, but we create actually a rectangular ring. Okay, here is the detail lah. Okay, what we will do is actually we create for VDD and VSS first. Okay, actually that is actually the power ring. Okay, so this is one way. Okay, or we can set this. Okay, the bottom, top, left, and right using the what we call as the ICC command. Okay, so in lab 2 we prefer using ICC command because in industry most of the tasks normally done in ICC command, and the advantage is actually the software will become um, faster actually in using the command line instead of GUI based. Okay, we go to the window button and click on this, so we see it side by side for easy monitoring the progress lah. Okay, so we add the power ring. So similarly we can put the comment first so that we can trace it easily in our log. Okay, and even in our history we can trace it easily what actually has been done. Okay, so for the power ring, so this is actually the command under the ICC shell. Okay, we create the rectangular ring, and then similarly the slash here is actually to show the different lah on different line. If you want to make a straight one line, just remove it and then bring all those to become a single line. Okay, and then we enter it, then we can see the different here. Okay, we have the power, you see it, we have the power line, and also power. When we talk about power, it's actually referring to ground and also VSS, right? To see in detail, we can actually zoom this lah, but we still need to use the window button and then zoom it. Okay, just use the what we call the mouse scroll button. See VSS and VDD. Okay, and then I think this is VSS VDD, and this is actually the IO. So it's similar to the one that we have discussed in our lecture on topic of IO or IC floor plan, okay, under the physical design. Okay, we have successfully finished what we call the adding the power rail. So what's next? Actually, we will place our design. Okay, so place your standard cell. So to do that, okay, we can use the GUI, okay, or use a line under the IC shell, command line. So similarly, maybe we can put the command first for easy trace, and then here is actually the command. You enter it, you will do the place optimization, I think. Okay, placement lah. Okay. We can see the all those outside block now is being moved to the inside the chip. Okay, so this is actually the floor plan lah. Okay, how the uh, location of the core inside the core of the chip. Okay, we can check it if you like to see it. Okay, in detail. See, we can see it clearly. So what is actually the inside the block, right? And also the power, and also the VDD, and also VSS, the port, the IO port, and this is actually the core area that we have, same as we discussed in our lecture. Okay, the core area. So inside core area, we have different element inside it. Okay, you can zoom in to see in detail. Okay, all right. Okay, this is actually to implement your multiplier. Then you press the window button again, and then you click on the IC shell. All right. So at this point, you should probably change the visibility of the metal layers of the standard cell pins. Make sure to check the pin and hit apply. Okay, this is actually the what we call the metal layers and all the layers involved in your layout. Okay, we can change it by using this GUI, and then click on the layer that you are intended to see it, and then you click apply. Okay, all right. For example, okay, maybe I can show you example. Okay, make it bigger. Okay, we see the actually pin button, pin here. Okay, pin, you tick on this. Okay, okay, and then we can untick on it. Okay, and then we can apply lah. So for example, we click on this, and then we can click apply, and then we can see it. Okay, that's will detail lah. You can see detail of the pin. Okay, you can even zoom it more lah, into more detail. Okay, and then you can untick it again, then apply, and then it's all of the information gone. So depending on the visibility that you are interested to see. Okay, okay. Let's say we remain the pin. Okay, you want to see it, so you click pin, pin, then you apply it. Okay, by this time your chip light will be seen like this one. Will be seen like this. Okay, what's next? We will do the connection power. Okay, so far we only have the power. Okay, ground and VDD, and also the logic inside the core area. So what we need to do next, actually, we do the connection between the power rail to the internal logic inside our core area. So to do that, we can do, as I mentioned, using the GUI or using the ICC shell. So to do it using GUI, you go to the pre-route. Okay, pre-route, and then pre-route standard cell. Where's the word? Pre-route standard cell. Pre-route or pre-route standard cell. I think I think this one lah. Either these two lah. Okay. Oh ni, this one. Pre-route standard set. Okay, we can see the dialog box appears, and then what we'll actually do, we will just tick lah. Okay, the important what we call setting that's required lah. Okay, connection mode. Okay, routing option. Okay, right. For this case, we shall use again using the IC command shell. Right. To do that, we go back to the window button and then go to the IC command. And so we maximize that. Okay, make it side by side. Again, using the window button. Then okay, and then we go to ICC command. Then we put the command first for easy retrieval of the information. Okay, then we put the command, and then now we type the instruction. Okay, and now we do, and then we perform. We have performed the pre-route. Okay, okay, we have performed it, and then what's next? We set the clock. Okay, just now we have do the connection between the power rail to the block lah. Okay, if you like to see it, maybe we can zoom in again using the to see the effect lah. Okay, and then we zoom it to see the effect of the command lah. Okay, it's not able to see it clearly. Maybe after we finish our step, then we can see it. Okay, all right. Here we minimize it. Okay, and then we do the next step, which is we assign the clock. Okay, those block that requires a clock, then we do the step lah. Okay, we can similarly go to the UI. Okay, under the clock. Okay, under this one. Okay, and then we set the clock tree synthesis option. Okay, but in this step, we will, as mentioned, we will use the ICC command. So what we do is we put the command first and then put the instruction. Then we enter, then we can see the effect lah. It's still working. Okay, now we can see the interconnection, the clock interconnection. This is interesting for you to see. Okay, to see it, okay, you can zoom in and then you can see now we have the clock line. Okay, clock line connected to your logic unit lah, which requires the clock. So we can see here, maybe we can zoom a bit on this one. This is actually the clock source. Okay, your clock, main clock source. Okay, you see it's labeled. Okay, main clock source, and the width and the length and so on. Okay, and then it goes through the required clock. Okay, so this is actually the clock spine. You can see it, the clock spine. Okay, and then the green also the clock spine that goes to the across the chip. Okay, we have three. 1, 2, 3, 2, and then 3. Three green colors of clock spine that separate the clock distribution across the chip. Okay, interesting, right? So to do next, actually we do the timing. We check the timing. So we need to press the window button again to make it active, and then we put the command again. And then we report this instruction, report clock tree. And then it will report to you all the clock tree information. Maybe we can make it bigger. and then we can see all the information about the clock lah, fan out, okay, then the what we call the all the information lah, right? All right. Okay, I think we can proceed to the next one. Okay, someone want to use this PC maybe. So I think that's all. And then we shall continue for the next step lah, which is the check the timing and so on. Okay. All right. Thank you, everyone. Hope this will be helpful for you. Okay. Thank you.